Sometimes it breaks, sometimes it doesn't. Let's see what this is all about. Stick around. Hey everyone, welcome back. I'm Scott, Edge of 3D, and you know that. You clicked on the channel. There's my logo up here somewhere. It'll like that. So, about a month ago, I got an email from somebody just out of the blue and introduced himself, says he's sure that we've probably met at a 3D Rep Rap festival somewhere. And I'm sure we have because we've been at the same Rep Rap festivals. But if you've ever been to one, you know they can be kind of crazy. And especially, I've never been there as just an attendee. I've always been in a booth, had my own booth, worked somebody else's booth, been taking care of dragsters, death racers, blah, 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 blah. So, meet a lot of people. Anyway, company is 3D-Fuel out of Fargo, North Dakota. The gentleman's name was John that reached out to me, and he asked what the process was to get their materials on my channel for testing. And I replied back to him. I said, it's real simple. Here's my address. Send me materials. I test it. And like I do with everybody, Polymaker is a channel sponsor. They have been for years. They don't get to see the results of my testing until it's public. 3D-Fuel doesn't get to see the results of my testing until it's public. I have had companies reach out to me and ask me if they could pay me for a favorable review of their materials, and I don't even respond to them. So, anyway, John sent me a big box full of filament, and it just so happened that about that same time, a viewer reached out and asked me if I could test 3D-Fuel's Pro PCTG. So that was the first one I tested because John sent me some. And then since PCTG and PETG are kind of in the same family, but they're different materials, we'll get into that more in a little bit. I've got both of them here together. Now, did my normal testing, tensile testing, LAR adhesion, Izod testing, and then heat sets and direct threads. I also did some temperature testing with the setups like this with the bases and the flags where they heat up and bend over. We'll go over that in a minute. And finally, I did these tests here where on this rig right here, let me find a couple of weights here and show you. I set all this up. When I get it first set up, I let the weight of the dial indicator push down on the piece, and then I zero the dial, and then I hang these 200-gram weights on here. And I check immediately after I hang them on there, and then I check after an hour, and then each day for 7 days. And then on the 7th day, I take the final reading. I take these back off, and I wait an hour, and I take one more reading. I take a final reading, take the weights off, take a reading right then, wait 1 hour, take a final reading, and see if it relaxes back any. We'll get over that in just a minute. I don't have that on the chart yet, on the testing yet. And lastly, the other thing that I do is I take this device right here and I tighten these to 0.5 nanometer, which I can't really see that, but it's got to be close to 0.5. That's 0.4. Let's try again here. And this is not their material. That's 0.37, so it went the wrong way. But I tighten it to 0.5 nanometer, newton meter, whatever NM is. And then I have this gauge here that I go through and I check the screw height to see how much the material crushes over 7 days. And I'm going to tell you right now that the PCTG and the PETG did not crush over 7 days. So again, that's a new test that I'm developing and I'm working on. So there's still a ways to go on getting all of that done. I got to turn this off here so I don't run the battery dead on it. And as I get that test more developed, it'll get included into the testing pages. But let's get on to this stuff right here. So let's go over the PCTG first. On the tensile test, 2 pieces didn't break, and my machine is set up to stop at 6 millimeters. So the way it works is it starts pulling this. When it gets to a 5 kilogram preload on the part, it stops. And then I hit the button to restart it, and that zeroes everything, and it zeroes the distance, and it starts pulling from there. And then it pulls until the meter peaks. And it records how far it's pulled, where it peaks at. And then as it drops back down, when it has a sudden drop, which is a break, it stops, records that value, that load, how many kilograms, or when it gets to 50% of its original peak, it stops there as well. This one broke. These 2 did not break, and they did not get down to 50% of the original load before they hit the 6 millimeters of pull. And that's all the further I have it set to go, because on most materials, that's good enough. So that's anomaly number 1 with the PCTG. Next thing's on layer adhesion. 2 of these broke pretty much at the same spot. A third one broke a little further up, closer to the transition. Now these pieces are printed standing straight up, so, but something triggered them to break pretty close to the same place. Remember that. Now the Pro PETG. Well, kind of the same scenario. 6 millimeters. You can see where they stretched out here, but they never broke. So I took the last one and I set the machine to go to 60 millimeters. So again, wherever it peaks out at, it continues to pull. Whenever it gets to 50% of whatever the total was where it peaked, it'll stop there, or if it breaks, it'll stop. This pulled all the way out to 60 millimeters, and I watched it, and it stayed right around 100 kilograms of force the entire way out. High 90s, low hundreds, the whole way, till it got to 60 millimeters. That's as far as the machine will pull, and you can see what it did there. So I didn't do that on the PCTG because that one was the third one and it broke. Now, layer adhesion on the PETG, I have to figure out what is going on with it, because let me get these all evened up here. They all broke in the same spot, and it's right at the transition. And it's right at the transition, it starts printing here, working its way up. So it's got to have something to do with the layer time. Now, there's more material here than there is up in this body here. So why did it break here? And is it because of too many? I have these seams set for random, or for nearest. So wherever it stops one layer, wherever it's, it starts the next layer, the nearest to wherever the last layer ended at. So I've got to figure out why. All 3 of these broke right there together. Now, I don't know why it's doing that. These 2 of them broke close to the same, third one didn't. So next, before we go over and look at the charts, and we look at the heat stuff, if I have one complaint on these rolls, you'll see this space spot right here. And that doesn't bother anything, except in the dry boxes that I use from Polymaker, I run them on the rollers down inside, and the rollers are so tiny that it drops into these and it hangs up there. And then it has a terrible time pulling it through, so I had to hang it on the spindle in there like this. But I mean, that's nitpicky crap. So next we'll look at the heat testing first. So I printed the flags, put them in the oven, and let me get transitioned over here to that screen. This is not where I want it out on the screen. Let me get my mouse found and bring this over where we can get that. There we go. That's much better. This is at 80 degrees, and I put them in there, let them go for 30 minutes at 80 degrees, and then I take the picture. And you can see they're standing up normal. This is at 85 degrees, and if you look real close right here, you can see the Pro PETG is starting to develop this little knee sticking out of the back of it. I don't know what else to call it. This is at 90 degrees. I zoomed in and got a picture of that. Here it is at 90 degrees. It's still standing up good, but it's got this piece that's sticking way out back here that I have no idea. The PCTG is still just fine. And there we go at 95 degrees. You can see it's starting to bow a little bit. It's got another one of those little spots starting to show up here. It's almost like the material's growing and blowing out back there. PCTG, you can see here against the edge of the camera screen, it's still pretty square. And here they are zoomed out. This is 95 degrees Celsius. This is 100 degrees, and they're both starting to give out. The PETG more so than the PCTG, but they have softened. 105 degrees, it's all over with but the crying at this point. They fell over. So, and now let's look at the creep testing here. And let me get those brought up. We'll jump over there. That's the test with the dial indicators. And the two on the left, this is the Pro PCTG and the Pro PETG. These right here are Polymaker materials. They're new in their old PETG formulas. But this is when I first hung the weights on there after I zeroed everything out. And mind you, the meters spin backwards. So this started at 0 and it's a 0.86 inches. This one is a 0.88 inches. Then we go to the end test here. This is at the very end, and this was showing a 0.99. This is showing a 0.106. So over 7 days, this deflected 0.13 inches on the PCTG and 0.18 inches on the PETG, which is 0.33, 3/10 of a millimeter here, 0.45 millimeters here. Now, I took the weights off and let them relax back, and they returned back to this one is setting in you got to again, these meters run the other direction. So this is 10, 20, 30. So this right here is setting at I wrote it down as a 0.34, and that's wrong. It's at 0.26. And this one right here is, I wrote it down as a 0.42, and it's wrong. It's a 0.38. So I wrote my numbers down wrong, but this is where it relaxed back to. I will put up here on the screen what the millimeters are. And after an hour, it didn't change. So I take the weights off, check it right then I wait an hour and see if it's relaxed anymore. And after an hour, neither one of them changed any at all. They stayed solid. So next, we'll just jump over and we'll look at the charts on my website. And here you go. Link is in the video description down below. It's changed a little bit. Now you have dark mode. So when you open it up, if it looks like this and you want dark mode, one button right there. Click it, light to dark. And I've added a polymer reference page back here. And this just goes over the different polymers that I've tested, what their family is, typical examples, if there's any benefit to annealing, what annealing does. typical temperatures, whether or not they need an enclosure, moisture sensitivity, and then my that looks about right uh, notes on what I think of the materials. So, my opinion mixed with a little bit of research, but the chart view is just getting to where it's too big to go pick out an individual material in there. So, let's go to the comparison view. Let's run down here and grab these two new 3D Fuel materials. And let's jump back up here to the comparison. Now, the Pro PETG actually scored a little bit higher, like 5% higher in the x-axis brake load, but we're talking 5%. Now, yield point, they yielded at about the same place, 4.57 versus 4.60. That's 3/100ths of a millimeter. That's not even enough to see with the naked eye. So they yielded at the same point. The only break I had was one piece of the PCTG and it broke at 4.77 millimeters. Now, here's where the PCTG starts to shine. Layer adhesion. 134.17 kilograms versus 83.3. That's a 60%. Even though they broke funny and can't explain the reason for the breaks, where they broke at, especially on the PETG, that's still a 60% increase in strength over the PETG. So that's where the PCTG really starts to shine. And as you've seen in the heat testing, it's good about 10 degrees warmer as well. Direct threads, PCTG again 65 versus 54.95 for the PETG. And then when we get to heat set, they flip flop. PETG hangs onto a heat set a little bit better than PCTG does. I don't know the science behind it. These are just the results. And finally, the Izod shock test, that's the hammer hit. 24 versus 23.33. The PCTG was a little bit stronger material. And if we go over on the chart view and we go down here and find them, they're not the lowest. Long way from the highest. But here we go. Here's our PCTG at 24. Here's the Pro PETG at 23.33. So they're near the bottom for the shock strength, but otherwise they're good materials so far for me. As far as real world, I have been using this to do some other tests that on a different day, different time, not related to the material. It was related to some processes. But what I have done is on my Reaper, you can see there's Pro PCTG already showing up on this car. The rear subframe, the U-joints right here, and you can't see inside there, but the gears inside the differential are the PCTG. Try it out and see how long it lasts. I actually built that for a different video. You'll see it if you hit the subscribe button and the bell icon. When the video that's featured in goes live, you'll get to see all about it. So 3D-Fuel, American company. They're based in Fargo, North Dakota. The company that I work for is in Fargo, North Dakota as well, or the boss that I report to, she's in Fargo, North Dakota. So American company, made in America. Good people, had lots of conversations with him. They have filament profiles for about every printer, and let's actually just jump into that right quick and I will show you what it is. So let's just take the Pro PCTG and let's just grab the Midnight Black here. Doesn't matter. Scroll down here, ready to go print profiles. Click on that, brings you to this right here. Select your printer. I printed this on the CD4 Plus, so clicked on the CD. Now you got to read here a little bit because it doesn't show up quite right on the CD because they don't offer that as a base material in their CD Studio, which their CD Studio is Bamboo Studio reskinned. Now it shows up fine in Bamboo Studio, but it's a different story for a different day. Well, I think it does. I haven't done that. But you click that, you get your JSON, you import it into your file or into your slicer, and you're good to go. And as you can see, they have it for lots of different printers. Most all of their filaments have profiles. They have the printers in their house, in their shop, in Fargo, North Dakota. They actually print with this stuff. They actually tune them themselves in house. If you find a printer on here, more than likely they have that printer and they've been running the materials on that printer to tune it. I'm doing some of their PLAs right there on the Bamboo. I grabbed their profiles right off their website, uploaded them into Bamboo Slicer, bam, boom, printing, all good. So, um, price wise, right now, this is the week before Black Friday, so I'm assuming these are sale prices. Normal price on the PCTG here is $29.95 a kilogram. It's on sale for $25.46 right now, which is 15% off. And normal price for the PETG is $28.95 a kilogram. It's 10% off at $26.06. So the PCTG is a little bit cheaper right now. Links to their website in the video description down below. They're not affiliate links. I get nothing for it. Like I told John when he reached out and asked me what it takes to get these materials tested, send me the materials, I test them. Just like I do with Polymaker, Soriatech, anybody else that sends me materials to test, they don't get to see this until you see it. So when you click on this video and it's live, that's the first time that 3D-Fuel gets to see it. That's the way I do it. I don't take payment for testing. And, I do have channel sponsors. Polymaker is a financial sponsor of the channel. They don't get to see their videos first either. So I do have people reaching out to me almost on a daily basis asking to pay me for favorable reviews of their materials, and they're generally companies from China with names this long that I can't say, and I just ignore them. I'm not going to get into that and do that kind of stuff. Links down below, link to my website down below. If you want to support my channel, links to my coffee account down below. Buy me a coffee. Links to the print settings because on the Tensile testing and the Izod testing, that's just 999 walls. On everything else, I use Voron standards, 4 walls, 5 layers, top and bottom, 40% infill, blah, blah, blah. I'll put that down in the video description as well. Buy me a coffee, buy me a super chat, whatever they call it here on YouTube. It all helps keep the materials testing pages free. Eventually, they're going to get to a point where if I don't get enough support that way, I'm going to have to do the um, Patreon subscriber thing just to keep up with it. So that's it for now. More testing coming. 3D-Fuel, link down below. Appreciate each and every one of you that watch these all the way to the end. Hit the thumbs up if you like it. Thumbs down if you don't like me. Hit the subscribe button if you want to subscribe to my channel. Helps on the algorithm on YouTube. And leave a comment because that helps as well. Now, I did have somebody reach out to me in an email and say they really like watching the breaking, the testing, and the breaking of the parts. So rather than just transition right to my outro, I'm going to go ahead and all of the breaks that I recorded with these materials, sit back and watch. You can see it all break. The Izod test. I don't record the thread testing because that's anticlimactic. Occasionally I'll have a material where the heat sets will explode, but these didn't. They just pulled out, so there was no need to record them. So the tensile testing, the layer testing, the layers broke, the tensils didn't, and the Izod shock test. Little video of that. Thanks for watching, and as always, till the next one, peace out.